So let's look at some aspects of Pythagorean triples. So Pythagorean triples are of course triangles, right angle triangles, in which you have the sum of the two squares equal to the third square, where all these numbers are natural numbers. So they are neat natural numbers. Usually that's not what you will get. You'll get square root of something and so on. So when you get these, the questions will always have nice round number answers. And there are a lot of questions in when children are introduced to Pythagoras theorem, and when you are doing many of the trigonometries and all that, there will be a lot of questions in which you will just be doing Pythagoras theorem repeatedly. Yeah? And you will use these numbers repeatedly. Okay, so for the Pythagorean... So how do you find the Pythagorean triples? I think that's an interesting exercise. And you can make a table of two numbers m and n, where m is little more than n, or m is more than n, that's it. Right? M has to be always greater than n. And you make a little table with the children. So here, let's say you have 2 and 1. Okay. So the first column is m square, which is 2 square, which is 4. The second column is n square, which is 1 square, which is 1. Okay. Third column is simply m square plus n square, which means the sum of these two columns. Fourth column is m square minus n square. And the fifth column is 2mn, 2 times m times n, which means 2 times 4, 2, 4, and times 1 is still 4. So this basically gives you a Pythagorean triple. Okay, this will always be the highest side, which is the hypotenuse, and these will be the two smaller sides. So you can take any number. So you can take 3 and 1. So 3 squares, just a fun exercise because it's simple squares, and if you have done squares, it's easy to do. So now you say, okay, 9 plus 1, that is 10, 9 minus 1, that is 8, and 2 times mn, which is 6, which is actually the double of this. So you will not always get unique Pythagorean triples. You basically got the same Pythagorean triple as 6, 8 and 10, but in a different order. If you notice, these orders can easily get flipped. Yeah. Okay, so let's take 3, 2. 3 square is 9, n square is 4. If you add the 2, you get 13. If you subtract the 2, you get 5. And if you do 2 times 3, that's 6 times 2, 12. So this is a Pythagorean triple, which is 12, 5 and 13. So like this, the exercise can be how many unique Pythagorean triples can you identify. One of the things you'll get out of the exercise is a practice on m square, n square. Another thing you'll get is actually exploring substitution. So even if the children have not yet done algebra, when you say you're squaring this number, you're squaring this number. If you introduce them to square, even if like abstract algebra has not been introduced, you can go about doing some of these things. They may just have done linear equations and so on, and these are squares, but you can do it. Right? So that's one aspect of it. Second is you start identifying that multiples of this will come, which means if I have a Pythagorean triple, its multiple will also work. That's also important to know, because in any question that they are solving, they are going to get these multiples as well. So that's also very useful. That also needs to be done. Okay, so these are two simple things that we can learn about Pythagorean triples and apply it. And you will get many questions that will have something listed. You have a circle, you have a chord, you have a radius, right? And what is the distance from the chord? So if you have half this distance already given, so let's say this one was 6 and the radius is 10, then you know this is 8. So these are examples of things that you can find by just remembering what are the basic Pythagorean triples, finding the multiples. If you see 6 and 10, you know that, okay, what's common between them is 2. If I remove the factor of 2, this becomes a 3 and 5. Yeah, I know what is the third side. Yeah. So some of these simple things, if they can look, then they are solving for patterns rather than solving just doing calculations. So this is the first part.